Okay, so in this particular lesson will be a little brief introductory on triangles, and a couple of and Euclid's theorem. We'll talk about that, okay? And some basic triangles, some basic relationships of triangles. Okay, so let's go ahead and go through this. All right. So the first thing I want to mention is what is a triangle? So remember, a triangle is basically a closed geometric figure, okay, that has three sides. And the thing to keep in mind is that, let's say we'll call this point A, we'll call this point B, and then we'll call this point C. So let's say you start at point A, travel straight to point B, and then travel straight to point C, and then travel from point C to point A. So we're going in this direction. I'm just choosing a direction, right? And go like that. We're going to end up at point A again. So we start at point A, go to point B, go to point C, end up at point A. Okay? Sorry, let me make that straight. All right? So just something to keep in mind. All right. And another thing that we want to talk about, okay, is called Euclid's theorem. Euclid's theorem. A lot of theorems in geometry. So if you're going to take a geometry course, you'll need to get used to all the theorems, lots of rules. Okay, so, but it's a fun course because it's very visual. Okay, so that's what this is. Okay, so Euclid's theorem. All right, what does that mean? Well, first of all, the theorem is a conclusion that is proved to be true through deductive reasoning. Okay, so when you think of theorems, okay, they've been proven through this process, and deductive reasoning is a process of reasoning from one or more statements or premises to reach some kind of a logical solution. So that's what deductive reasoning is, just in case you forgot. All right, so Euclid's assumption is basically a given line and a point, not on a line. One and only line can be drawn through the given point, parallel to the given line. Now, that's a mouthful, all right? So that's going to be a little difficult to comprehend without a picture. So let's draw a nice picture, and you'll see what it means. Okay, so Euclid's assumption. And it'll be so much easier if I go ahead and draw a picture rather than writing all that out. So I'm going to do that for you. Okay, so we're going to draw two parallel lines. All right. And let's say there's a given point on this line. And so we have a given point. Wait a minute. And let's say this is our designated given line. That doesn't read well, does it? Okay, let's try this one more time. So the line down here is the given line, and the point here is given as well. So that's what's given to us. And Euclid's assumption means that this it means that this line right here, the one that wasn't given, this line is going to be parallel to the given line, which is at the bottom. Whoops, again, I slipped again. All right. And it's going to be through that point as well. Okay, so through the given point. Okay, so let's repeat that. The line that I'm with the green arrow is parallel to the given line at the bottom, and it also goes through that given point. All right, so try this again, right? If you have a point and that given point in this given line, I don't like the way that looks. It's always crooked here. Sorry, I'm a little finicky when it comes to diagrams. Okay, still a little crooked. So let me do that one more time. Okay, so this given point and this given line, Euclid's assumption states that this line going through that given point is going to be parallel to the orange point, which is given, okay, and through that given point. So the red line is going to be parallel to the orange line given through that point, through that given point. It's a mouthful, I know. Sometimes even I have to think how to say it. So I totally get it. That's, a little bit crazy, but that's what it means. Okay? So that's what Euclid's assumption is. Kind of interesting, isn't it? Geometry is a very fascinating subject to me. So Euclid's theorem states that, let me use a different color actually, states that the sum of the measures of the three angles of any triangle is 180 degrees. So again, a picture's worth 1,000 words, right? So let's say you had, let me just do a different color. So let's say you had a triangle. And we'll call this point A, point B, point C. A, B, and C are vertices, right? Okay, and we have two parallel lines. One is going to go through the vertex B. The other line is going through vertex A and vertex C. All right, so these are parallel lines. So make sure we understand that. And if this situation occurs, right, then angles, let's label these angles. 1, 5, 3, this will be angle 4, angle 2. So angles 1, 5, and 3 sum up to 180 degrees. The interior angles of a triangle sum up to 180. Okay? So that's kind of interesting, right? So kind of remember that, all right? So they sum up to 180. Okay, so the sum of three angles sum up to 180 of any triangle. Whether it's obtuse, acute, doesn't matter. Okay? So let's write that down, right? So the measure of angle 1 plus the measure of angle 5 plus the measure of angle 3 will equal 180 degrees. There's a proof of that, but for right now, for the time's sake, let's just agree that those three angles add up to 180. So if you're giving a problem right? So let's say you had you know what, let me just draw the triangle. Okay, let's say you had that. Okay, so let's say we designated this point as A, or this vertex is A, this vertex is B, this vertex C. And we're given this as a 120 degrees, and this is 17 degrees. We want to find out that angle. So the rule of thumb is we want to find the measure of, this is what we're doing, we're going to find the measure of angle A. All right? And very simple, right? We said that the interior angles sum up to 180. So you basically should be writing, okay, should be writing this. The measure of angle A plus the measure of angle B plus the measure, plus the measure we said A, B, and the measure of angle C must equal to 180 degrees. All right, so let's plug in what we know. We don't know what measure of angle A is, but we do know the measure of angle B from the diagram, which is 120 degrees. We do know the measure of angle C, which is 17 degrees, and all three of those angles have to sum up to 180. So now it's just algebra. We can go ahead and combine 120 and 17, which we know is 137. And if you subtract 137 from 180, you will get 43 degrees. Okay, so angle A is 43 degrees. All right, pretty easy problem, right? Here's another one. Let's briefly talk about angle relationships. Angle relationships. All right. Let's draw a diagram. And draw a transverse. Okay, this is given as a 90-degree angle. We know this is 43 degrees, and we know this is 60 degrees. These are the given angles. And then we're going to label this as angle 3, angle 4, angle 5, angle 1, and angle 2. So we want to find the measures of angle 1. So this is what we're going to find. We're going to find the measures of angles 1 and 5, or 1 through 5 actually. I'm going to find all of them. So 1 through 5. Okay? All right. So let's start off with angles 1 and 2. So measures of angle 1 plus the measure of angle 2 plus the measure of angle, well, they're 43 degrees, right? Must add to 180. Why is that? Because angles 1 and 2 and the 43 degrees are inside that triangle. And we said the sum of those angles, those three angles, should sum up to 180. So I'm going to write an equation, right? Measure of angle 1 plus measure of angle 2 plus 43 degrees equals 180. Again, fill in what we know. The measure of angle 1 is 90. Why is that the case? Well, it's because this angle 90 degrees, and if we draw another box below that, you notice that it's a straight line. So whatever that 90 degree angle is, angle 1 is going to be equal to that, okay? Because two angles adjacent to each other form 180 degrees. So if you have 90 degrees, you would need to add 90 more to get the 180. So measure of angle 1 is in fact 90 degrees, okay? And we still don't know measure of angle 2. But we can easily find that using a little algebra. All right, so let's combine like terms, 90 and 43 is going to be 133 degrees. That still equals 180. Subtract the 133. The measure of angle 2 is equal to 47, because 180 minus 133 is 47 degrees. And that's it. So it's pretty simple. So you need to know those basic theorems from Euclid's theorem, right? Those assumptions and theorems, or his theorem. Okay? So that is pretty easy, right? You just have to know the basic the theorem, all right? You're probably wondering who Euclid is. Well, he was a mathematician from Alexandria, Egypt, and his nationality was Greek, and he was born in the mid-4th century, okay? And he was highly influenced by Isaac Newton, and he's the one that came up with this theorem. So, interesting person, right? Okay, and then using this same diagram, okay, we can find the measures of angle 3 and 4 and 5. So this should be pretty easy because it's very similar to what we just did. Let's use a different color. So, we can start here. So the measure of angle 3 plus the measure of angle 4 plus 60 degrees equal 180, because those are all interior angles of a triangle. We have to have the 180. So now let's plug in what we know. Measure of angle 3 is 47. Do you know why? Because if angle 2 is 47, then so is angle 3, because they're vertical angles. So we're going to designate angle 3 as 47 degrees. Does that make sense? And now we combine like terms. 47 plus 60 is 107. Subtract 107 from 180, and you're going to get, what is it, 73 degrees? All right, and if you want to find the measures of angle 5, then we know angle 4, okay, plus angle 5 need to be supplementary, which they have to add up to 180. So the measure of angle 4 plus the measure of angle 5 need to sum up to 180 degrees. So if you know angle 4 is 73, and you take 180 and you subtract 73, then the measure of angle 5, let me write it here, the measure of angle 5 will in fact equal 107. 107 degrees. So we found all the angles in that diagram. And you notice all the information that we previously learned, including the information from this lesson, you put it all together and you're able to find all these angles in that diagram. Okay? It's kind of like a piece of the puzzle. You can put them all together. You know one piece, figure out the other piece based on theorems and assumptions and all that other good stuff in geometry. Okay? All right. So just one more thing. Okay? I want to talk about briefly the classification of angles, okay? So the first one is the acute triangle. And that's basically all the angles inside the triangle are acute, which means less than 90. Okay? So all angles are acute. Okay? So that means this angle, and that angle all add up to 180, but every one of those angles are less than 90. Okay? The other triangle, which I'm sure you have seen multiple times, is the right triangle. And a right triangle would be something like this. And the angle here, those two lines are perpendicular, which means they'll form a 90-degree angle. Okay? So the definition is one angle is in fact 90 degrees, and that happens to be this one. Okay? Pretty easy, right? And this other angle is pretty easy to identify. It is called the obtuse angle. Obtuse triangle. And that will look something like this. Okay. What does that really mean? It means that one angle is obtuse, which means greater than 90 degrees. And that would be this angle here in this case. All right? So all three interior angles of a triangle sum up to 180, but one of those angles must be greater than 90. And that's this one. Okay, the one in black here. All right. So 3 more. Okay. The isosceles triangle. You may have heard of this in your high school geometry class. So, to keep things simple, isosceles triangles means we have two pairs of angles that are identical and two sides that are identical in length. And the two sides will be opposite of each other, but equal length. So let me say that one more time. The opposite sides are equal and the opposite angles are equal. Okay, that's called an isosceles triangle. And the other one is called the equilateral. Alright, label that as triangle. Lateral means side, equal meaning the same, right? So equilateral means that all sides of this triangle would be equal, and we denote that with a line going through it. Okay, and it also means that each angle is 60 because all sides are going to be forming those angles equally. All right. Okay, one more, and then we're finished. This is called the scalene triangle, which means no sides are equal. They're all different lengths. So it would look something like this. Okay? None of those sides are equal. Okay? So none of the sides or equal. All right? Okay, so there you have it. Very basic concept of triangles. I hope that this video was helpful. Thank you for watching.